remember what we did yesterday. That's going to help us with today's. Let's pretend. How would you change all dogs go to heaven into an if-then statement?
Dogs go to heaven.
Dogs either go to heaven, then they go to heaven.
Do that.
Yeah, you could say that. Or
Dogs go to heaven.
if the animal's a dog, it will go to heaven, or something like that.
If the dog goes to heaven, the dog
Then
goes
it
to
is
heaven
dead.
if and only if it
Then
dies.
it's dead.
I'll just say if it is a dog,
It is dead.
then whose dog? Then it goes to heaven. So let's pretend like, I don't really know that this is true, but let's pretend that we know that's true.
Then it goes to heaven.
So we'll say that's a true statement. We'll pretend. Okay.
It is a dog.
I have no idea. What is so this is the original statement. What is the converse statement?
If it goes heaven, then it is dog.
Yeah, I remember. If it goes, so this is the converse.
If it goes to heaven, then it's not.
Like I said, if it goes heaven, then it is dog.
It is a dog. I wish I could write faster. Is that a true statement?
Yeah. No, it's not.
Because it could be a person, right? So that's false.
Could be cat.
Okay, you guys,
You said dogs go to heaven. You said dogs is converse.
it's converse, yeah.
The next one's inverse.
Okay.
Dogs are nice for cats.
Do we remember what inverse meant?
Flip it, so it'd be like
If it's
if it is a dog.
No.
No.
Oh, it's not.
This is a flip. Inverse is not, right? So if it is not a dog,
Then it is a cat.
Then
I
it's
don't
dead.
know if that.
then
Yeah.
it does
Not live.
does not
Live.
go
To heaven.
Not.
to heaven.
So I have to be a dog to go to heaven.
Okay,
Yes.
is that a true statement?
No.
Oh, so therefore we don't.
For the same reason this is false, this is false. Converses and inverses happen to be logically equivalent. These two are saying basically the same thing in a different way. And then you guys remember the last one? It was called a contrapositive
I don't remember. So the not is just like you just put a not on everything.
for inverse.
Oh, isn't that the opposite? Like the switch
Okay.
gears?
Contrapositive does both. You switch the order and you make it not. So if it does not go to
It is
heaven,
not a dog.
yeah.
Then it is not a dog.
You mean a noose?
What?
You said tie a knot. Like.
I
Okay.
know how to tie a knot though.
Emily, you have a lot.
Okay, if we assume that the original statement was true, is the contrapositive true? If it does not go to heaven, then it's not a dog.
No.
Wait.
Yes.
Yes.
If we say all dogs go to heaven, and it doesn't go to heaven,
True.
then it can't be a dog. So the original statement and its contrapositive are logically equivalent. They are saying the same thing in a different way. Might be a little bit confusing, but if you stop and think about it, it might take some time, but it does make sense. If you're saying all dogs go to heaven and something doesn't go to heaven, then it can't be a dog. So anyway, these two are the same thing. And these two are the same thing. So if this one's true, this one will be true. If this one's false, this one's false. But same thing with the converse and inverse. These are contrapositives of each
Well,
other.
not all dogs. Hairless dogs, they don't go to heaven.
Okay.
Yeah, you're right.
And we're just
Because they're just trying to be cats.
cats usually have hair too.
Imagine slapping a hairless cat.
Have you ever thrown a cat downstairs? It's really
I think
funny.
I'd go.
It's
I wouldn't
really
throw a cat
funny.
down the stairs.
It's really funny.
Does it lay on its feet?
No.
You just hear this is about
Jake, can I throw your
Are you a cat lover?
His name is Cat.
No.
It's just
Come on,
sad.
Jake.
You said if you think
Well,
really
then
hard on
well,
it.
you have to ask back and give a dog
Okay.
and it won't grow it.
Hairless cats are
So,
Listen
listen up, guys. Hush, hush. Okay, so I know this, let's pretend I know that this first statement is true. So if I say, trying to think of something that won't make you giggle. Puddles is a dog, then what can I assume?
That
Dog
dog
is
is Puddles.
Okay, Puddles goes to heaven.
Wouldn't they?
So if you're just using the if then,
That was the dog died.
hush. Okay, if you're assuming this is true, and then I say Puddles is a dog, therefore Puddles is going to heaven, you're using a form of logic, a deductive form of logic called modus. I probably can't show
I get it now. The last one.
Let's go.
I understand.
Okay.
Modus
Yeah, I
ponens.
understand it, what you're saying.
No, that's the other one. Threw me off.
It's probably because Trevor threw it.
Okay,
Whoa.
so modus ponens, it's a fancy, it's like a Latin, but it's just saying, you're basically kind of repeating the if-then statement. So, if Puddles is a dog,
Means there.
my dog's name is Puddles, Puddles is going to heaven. So that's modus ponens. I don't really have a dog, so.
Oh, okay.
Oh, the dog died.
I get the last one now. In the top.
Okay, so that's kind of what that means. If A then B, you guys remember this from yesterday, and A happens, then we can assume therefore that B will happen. Okay, it's very simple.
Can I ask?
If A then B, and A happens, therefore B will happen.
So,
Can I ask a
so
question?
you,
What?
oh, me?
Yeah.
So if you kick a dog down a
All
hill
right,
and
that's
he
fine.
dies, then you could say the dog goes to heaven.
Okay,
Can you write that symbol on the board and say what it means? Because I'm gonna forget what we're doing.
what symbol?
The three dots.
Okay, this means therefore.
Can you still write it like to the side? Because I'm not gonna remember it.
I'm writing it right now.
Okay, yeah.
You just wrote it.
What? I forget.
Okay, the three dots means therefore. So logic people are evidently lazy because they think of a symbol for everything. They don't want to write up. This took me a long time. Anyways,
So it's kind of like gibberish math.
so if not B, it's not really math, it's logic.
See, this
But
is
you
what's
have to use
confusing me.
logic to do some math, like proofs. Okay, if not B is true, then what's going to happen?
Not A.
Not A. This is basically the contrapositive. Okay, actually, we can about this. The contrapositive is called modus tollens. Whoever said that earlier was looking at the book. Modus tollens. I'm pretty sure I'm pronouncing this right, but I'm not 100% sure. So if A then B, and we know not B, then not A. Therefore, not A. Okay. So, yeah, it's what we were talking about with the dog thing. If I know all dogs go to heaven, but I know something didn't go to heaven, then I know it wasn't a dog.
Okay.
Okay, so basically they gave names to this reasoning, modus ponens, modus tollens.
So.
This is called deductive reasoning. So do you guys remember inductive reasoning? We talked about it on Tuesday, I think. It's like noticing patterns and predicting what's going to happen in the future.
Oh,
is
using past
induct-
experience to predict it.
Yes, using past experience to predict the future.
Yes.
Is inductive reasoning 100% proof?
No.
No. Remember talking about that? Deductive reasoning, if you know this is true, then you know, and this happens, and this has to be true. So deductive reasoning is supposed to be like foolproof. If I know this is true and this is true, then this has to be true. Yeah.
Do I have to use the symbols? I hate the symbols, they confuse me.
I don't think they're doing much with the symbols, but it might show up in a couple places, so you do need to know it. So this just means not.
Okay.
So we need to.
The B would be like this part of the sentence, the A would be this part of the sentence. And this means therefore.
Okay.
That's new for today. That's, I think that's the only symbols they used. This means if A then B,
Okay.
so if it's a dog, then goes
Because that
down.
means like
I'm
if
not
B
that
didn't
confused
happen,
anymore
A
then.
didn't happen.
I think I got it.
So we pretty much know
Okay.
what is the symbol.
So deductive reasoning. So we got one more though. We got modus ponens, modus tollens, and another one.
Trans-
Maybe I should think of a real example instead of A's and B's.
Thank you.
Christmas tree, A, Christmas tree.
Oh, I love. I love Chris. I do too.
I like
Did they do
zebras.
it?
Okay, I'm not gonna write it down because it would take me too long, but, let's say if you are
Sophomore.
do you guys know what a person who lives in Bartlesville is called?
Oh,
A Barshan.
Oh, that, yeah.
I'm
Barshan.
stupid.
Okay, if you are a Barshan, then you are an Oklahoman.
Martian?
Barshan.
I was born in.
It's true. Okay, if you are an Oklahoman, then you're an American, right?
Yeah.
So if you are a Barshan, then you are an Oklahoman.
Then you're an American.
If you're an Oklahoman, then you're an American. So what can I conclude?
Which means you're.
Now we are American.
If you are if you are a Barshan, then you are American.
A to C, because
Okay.
yeah.
That makes sense.
This is deductive reasoning also. It's called the transitive property, or the, I think they call it the law of transitivity on
Yes.
this one.
What a lot of
Okay, the way that I remember this word is it kind of looks like a train. Like car A is connected to car B is connected to car C. Therefore, car A and C are connected.
It really just, that makes sense. Like,
So
from the back to
train,
the-
like a train, transitivity. Anyway,
That makes sense.
so that helps me remember the word a little bit better. These two I actually haven't seen before this year. Like these books are new, so yeah.
I've got an example for that.
Okay, real quick.
Okay. All the animals at the zoo are zebras. All the animals at the zoo eat marshmallows. So that means that all the zebras eat marshmallows.
You said it slightly wrong. All the animals at the zoo are zebras. All zebras eat marshmallows. Therefore, all animals at the zoo eat marshmallows.
Therefore, all the marshmallows are
I'm on the wrong page.
Wait.
Where are we at? Okay,
Every
so
student does work.
Oh,
Every student that does work goes to festivals, therefore every student goes to festivals.
okay, yeah. If you have false statements, you will get a false conclusion.
You got it from the book.
So,
I did?
There's a bun in here.
guys, shh, listen. There's one more word we want to talk about, and that is fallacy. You've probably heard that before. It's basically a false conclusion, like you're not thinking quite right. So if I said, if it is a dog, then it goes to heaven, and I say, well, if it's in heaven, then it must be a dog.
That's not true.
That's not a true statement. That's called a fallacy. Because if original statement is true, that doesn't mean its converse is true, right? It could be true, but it's not necessarily true, like the dogs go to heaven thing. So, like, if it's true both directions, what's it called? A biconditional. That was from yesterday. So, like, one of them is, like, Jesus died for us.
Oh yeah. That.
If you're a sinner, Jesus died for you. If Jesus died for you, then you're a sinner. Something like that. It works both ways.
If all people have sinned.
Yeah,
all people
I can't
have
remember
sinned.
exactly how they said it.
Don't worry.
But that would be a biconditional. Okay. Are you guys ready to go? We're gonna start now.
I'm confused on.
I'm gonna help you. I'm gonna help
I
you.
stabbed myself.
that doesn't.
Nothing.
Okay, number one.
Oh, whoa. I have a paper on that.
You guys write the assignment down already?
No.
Then one can speed up.
Will's feet are not in the chair. I don't know. I'll be honest. I don't know.
Fine. I can breathe.
Okay, number one, classify each argument as inductive or deductive. After surveying thousands of individuals, the Gallup poll predicted the winner of the presidential campaign. Is that inductive reasoning or deductive reasoning? Okay, based on past experiences, they're doing an educated guess of who's going to be the president. Inductive. Okay, I don't know if you guys remember, but like 5 years ago, nobody predicted Donald Trump to win, right? So
Except maybe
because on the polls, they weren't showing him to win. So if it's not 100% proof, that's inductive reasoning. They were just taking an educated guess based on, you don't poll the entire US, you just poll a couple thousand people. Okay, number 2, a driver obeys traffic laws or the driver receives a ticket. The driver ran a red light, the driver receives a ticket.
Deductive.
That is deductive. They're saying, given these premises, given these basic rules, this is gonna happen. So that, and they made a conclusion from those premises. So as long as your starting premises are correct, your deduction will be correct. Your assumption,
So basically, if they like predict that it will happen, and it does happen, it's deductive, and if they predict that it will happen, it doesn't happen.
It's more like, okay, on deductive reasoning, you got these set of rules
You got facts.
that like are supposed to be facts. Sometimes they can be false, but you're assuming this is true, therefore you know this is true. On inductive reasoning, I've noticed this happens. It seems like every time, so I'm gonna guess it's gonna happen again.
So it's just assuming.
Yeah.
So the
So
first one's like-
inductive is assuming,
so
I'm
the-
gonna go by that word, and then deductive is a fact, so it will happen.
Yeah, you're
Yeah,
saying
yeah.
given these as fact, if these are facts, then this is the truth.
Okay, and that's deductive.
Deductive.
So-
Deductive is supposed to be like solid. Inductive is a little more loosey-goosey. Of course, on deductive reasoning, if you don't start with the right facts, you're still gonna get the wrong answer. Number 3, in a civil suit, no witnesses testified unfavorably concerning the reliability of the defendant. So the testimony of the defendant was accepted by the jury.
Deductive.
That's inductive.
Yeah.
Probably true, but it's not 100%.
We'll never know.
Why do I have to weigh in?
Okay, I'm going to now skip to number 7. You guys ready? Okay, number 7, classify each deductive argument as modus ponens, modus tollens, or transitivity. So, on number 7 says, if A then B, and if B then C,
Oh,
therefore A then C.
That's trans.
That's transitivity. I changed the page, didn't I? That was my, yeah, if you don't know how to spell it, it's in the directions.
Wait, we jumped to number.
7. So leave space for 4, 5, and 6.
The
Oh,
number
so-
8
Would
is.
6 be inductive?
8 would be the modus.
Okay, we're not doing 6 right now. Number 8, if A then B, and A happens, then what's gonna happen? B.
Modus
Yeah, I wrote that one somewhere. Modus ponens.
And the last one is not modus.
Modus ponens is like just
Modus
restating the
tollens.
original statement,
Modus tollens, yeah.
and modus tollens is like the contrapositive version.
I remember the squeakies.
Wait, so this is Latin? Yeah. Those words?
Yeah, when the words are weird like that, that's like Latin.
Or Greek?
Yeah, Greek sounds more like
Yeah.
ends in a like, I don't know.
Oh, number 10 is
I'm not
weird.
really a language expert, but I don't think it's Greek.
Number 10 is weird.
Okay, number 10. If the measure of angle A equals the measure of angle B, so maybe they're both 90 degrees or something, then angle A is congruent to angle B. That is a true statement. Congruent means they're the same thing. So they're saying if you get the same measurement on the angles, they're the same thing. That's true. However, angle A is not congruent to angle B. Therefore, measure of angle A is not equal to measure
It
of angle
just
B.
canceled it out.
Okay, so they're saying if this is true, then this will happen. But if this didn't happen, then this is not true. Which,
Modus tollens. That's what I was
correct,
thinking.
modus tollens.
Dude, I have my hands.
Okay, got it. That makes sense.
Kind of.
Yeah, modus tollens always has the not statements. That's something you should look for.
You just answer all of them.
Number 11,
Oh,
if
transitivity.
I break my arm,
Or
then
no,
I,
it's 12.
hold on. Let me read it first. If I break my arm, then I will go to the hospital. I broke my arm. I'm going to the hospital.
Oh!
Modus ponens. That's the kind of restating the if-then statement.
So that's what
I broke my arm going to the
Is it
hospital.
number 12, transitivity?
Let's read it first. You guys are about to learn something on number 12.
Uh-oh.
All flags are cows, and all cows are radios. Therefore, all flags are radios.
Transitivity.
Okay, transitivity. Now, yeah, transitivity. Now that is deductive reasoning. The reasoning was sound, but the starting place was false, right? So you came to a false conclusion. But it's not because we didn't have the right reasoning, it's because we had the wrong premises, the wrong ideas to start with. All right, now I'm going to jump to 16. The last section.
But there's
16 says state a valid conclusion for each set of premises, then classify what kind of argument it is. So it's kind of this part, this again. But also we have to say what the conclusion should be. Okay, a cat is a mammal. All mammals have four chambered hearts. Therefore what?
And it has a 4-chambered heart.
Cat has a four-chambered heart. So you need to write that last part down. Therefore, cat has four-chambered heart.
What does that mean?
Chamber, it's like tubes running through the heart.
Oh,
That's
is
nasty.
that normal or not?
No, yeah, all mammals have that.
I think reptiles have 3 chambers and then fish
Like,
have 2.
chambers are like
Yeah. We have mammals.
chambers are like rooms.
Yeah. Yeah, I think it, if I remember correctly, one side of our heart pumps oxygenated blood into our lungs, and then the other
Okay.
side pumps oxygen.
What kind of reasoning did we use to say that the cat has four-chambered heart? Well, these are all deductive reasoning today, but which of these three kinds did we use?
Well, it's
No, it was cat is a mammal, four-chambered heart, cat, four-chambered heart. So transitivity.
So it's the 4-chambered heart and transitivity?
Well, you have to say, yeah, a cat has four-chambered heart, that's our conclusion. But what kind of logic we used was transitivity.
I got the answer for number 21 or 17.
I don't want the answer for 17.
Can I ask you a question and see if it's right?
No.
Okay.
Okay, on number 17, a triangle has two congruent sides. If a triangle has two congruent sides, the triangle is isosceles. Triangle ABC is not isosceles, therefore,
2 sides. Oh, not. 2 sides are not.
right, there are not two congruent sides, something like that.
2 sides are not.
There are not two equal sides.
No.
If it's not an isosceles, there are not two equal sides.
So that statement
Yeah,
also
3 equal
Moses
sides
Collins,
and 2
right?
equal sides.
Modus Collins, yeah, that has
Yeah.
the not stuff.
Okay, got it.
It's like the contrapositive of the statement.
So there are not two congruent sides.
Yes.
I'm kind of confusing 20, I think.
Jumping ahead here, I was only gonna go to 18. 18, if point Q, we probably should draw a picture for this one, this confuses people. If point Q lies on the interior of angle M and P, so angle M and P maybe looks like this or something. And Q is on the interior. Smart board screwing up. Alright,
Usually does.
yeah, it usually does at this point. If point Q lies in the interior of angle M and P, then angle M and Q plus angle Q in P should equal what?
M and Q.
M and P. And that's what it says on the problem. So that's a true statement. Then it says point Q lies in the interior of angle M and P. So what do I know?
Q
Okay. This confused the other class too. It's not as confusing as it sounds. So what they said, let me back up and repeat what they said. If Q is in the interior of this angle, then these two little angles add up to the big angle. That makes sense, right? But then they said Q is in the interior of this angle. So what can I assume? Therefore, what? Blows our minds. Okay, I'm going to say it one more time. We'll try one more. So they start off by saying if Q is in the interior, so not out here, because if Q is out here, this wouldn't work.
Therefore, Q is a line.
No. If Q is on the interior of this angle, then I know that these two little angles add up to the big angle. Okay, then I say Q is on the interior of the angle, therefore, what?
Q is a point.
It's a plane.
Therefore, Q.
Alright, therefore, what they just said is gonna happen. These two little angles add up to the big angle. But I'm not gonna say it like that, I'm gonna say it like they said it. Therefore, measure of angle M and Q plus the measure of angle Q and P equals the measure of angle M and P. So you just kind of repeat what they already said. They said if A then B, and then, whoops, not that one. They said if A then B, then they said A, so we're gonna say then B. It's modus ponens, but what are we gonna say? They said if
M and P equals Q.
they said if Q is on the interior of the angle, then the angles will add up to the big angle. Then they said Q is on the interior of the angle. So we're going to say then the little angles add up to the big angle. But we're not going to say the little angles add up to the big angle. We're going to say it like they said it. The measure of angle, I'm just reading this from the book. The measure of angle M in Q plus the measure of angle Q in P equals the measure of angle M in P. So you just need to rewrite that.
Okay, so we're just writing what they said, wait.
Yes, we're rewriting the second part of that sentence.
So then,
So basically M and Q plus Q and P equals M and P.
Yes.
And then it's minus common.
Yes.
So measure of M and P.
No. See the second part of that sentence when it says then blah 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 with all the measure angle.
Yeah.
So that's the part we're gonna say.
if you were running, then you weren't exercising. If you were exercising, then you were burning calories.
All right. Why don't you guys finish that up? Canyon's gone. And Marianne. That's it. They're both ready.
Except for Dan's left.
They're doing a cross-country meet. Okay, where was it?
She's back.
Definitions is only for your thing on your crew, and there's just like by definition, you just.
Mine's for fun.
Has not been fun. So, if he didn't use a good word, then
It's fine.
what does he have?
He's a, you don't use.
He doesn't have a good definition, right?
Yeah.
So, that's-
Oh, good.
If he didn't use a good definition, then the conclusion is he doesn't.
But that's what it says.
No, the not, yeah,
Oh, yeah.
he did not use a good word, so he does not have a good definition.
So if you do not use an unclear, if you use an unclear word, then you do not have a clear definition.
That's fine. You don't like this one? Yes.
I just come up with 19, 20, and 21. I'm not fast, I just know everything.
If 0 squared is 0
Yeah,
and 1 squared is
I
1,
look it up.
Billy concluded that 1 squared is 2.
Cellular
But
device.
this
I'm a Jane.
we notice,
Cellular device. Someone was on their cellular device.
Yeah.
is 18 minus 1.
Oh, that's one.
Yeah.
Yeah, so if it has the nots, like not something, it's fallen. If it just kind of repeats the if-then statement components, yeah. 18 was Poners, yes. I'll just call them Poners.
17